Hello students, Namaste, hope all of you are well. Today we are going to discuss class 11 chemistry chapter number 2 structure of atom. Before starting this chapter, I would like to say you something about how this chapter has been started. This chapter was specially being considered for atomic models. As all of us know, J.J. Thomson has given plum pudding model. Rutherford had given alpha scattering experiment model. Niels Bohr has also given atomic model, quantum atomic model. Many more scientists have given their atomic model. But there were so much deflections in their atomic models. So there was a necessary condition to know about the really which is the smallest particle of the universe of any matter. Already in the Dalton atomic theory we have read in chapter number 1 that atom is the smallest particle of matter. But because of a lot of fluctuations in their atomic model, so it was not considered that atom will be the smallest particle of a matter. Now, some of the scientists have already discussed about these things. As you can see here, I have already written on the boards the ideas of classical mechanics. Classical mechanics, after the quantum mechanics and classical mechanics, you must know about it. These ideas were developed by Galileo Galilei, Kepler and Newton. After them, these ideas have specially been developed into the atomic models. But then also in their atomic models, the lot of fluctuations in their postulates has came. After them, quantum theory was also proposed by Max Planck. Max Planck has proposed this quantum theory and it was applied by Albert Einstein and Niels Bohr. They both have applied this quantum theory, but then also there was a lot of fluctuations in the atomic models. So now question was, the things which we were going to discuss in this chapter are discovery of subatomic particles, electrons, protons and neutrons. After that we will discuss about the atomic models of J.J. Thomson and Ernest Rutherford. After that we will discuss about the wave theory, Planck's quantum theory, quantum mechanics. We will also discuss about Big Bang theory, light absorptions, light emission, spectra. We will also discuss about atomic models, quantum theory, the dual nature of matter. Matter is wave or particle, and we will discuss about quantum numbers, and finally we will discuss about electronic configuration in this chapter. Now the question comes, the need of discovery of electron. Michael Faraday and Julius Planck. There was a contradiction between these both. Michael Faraday in 1860 he had said that all the solids and liquid can conduct electricity. All the solids and liquid can conduct electricity. Now question was, what about the gases? We all know gas is an insulator. Gas do not conduct electricity. If it would conduct electricity, then in the atmosphere gases are present. Then it can harm human beings, but it doesn't happen. So now how to prove this gas conducts electricity? So in 1864, Julius Planck has given one experiment. He has said that gas also conducts electricity, but there is one condition: at a very low pressure and high temperature. High electric current, not temperature. High electric current at very low pressure and very high electric current. So he has done an experiment. That experiment is also known as cathode rays discovery or electron charge discovery experiment, electron charge tube experiment. This experiment was specially proposed by Julius Plöcker in 1864. He has taken an evacuated tube because vacuum is not possible in the earth. So he has developed one discharge test tube that was also known as evacuated tube. Evacuated tube means that a test tube in which the pressure is very low. And he has taken electrodes as a cathode and anode. Already we know that cathode means a negative electron and anode means a positive electron. After that, he has filled air inside that discharge test tube. He had taken the pressure towards 10 to the power minus 4 atmospheric bar pressure. He has connected both the electrodes with the generator which conducts very high electricity, that was 10,000 volts. And after, as he has passed the 10,000 volt current in this evacuated test tube, he has maintained the vacuum pump in this evacuated test tube. As the high voltage of generator has passed the electric current in this discharge test tube, evacuated test tube, he has seen that from the cathode one rays has been developed and it was moving towards the anode. As it was moving towards the anode, he has seen that near the anode there was a green glow. It was indicating that it is showing the fluorescent screen. As he has changed the electrodes material, he has also changed some other gases, but the same experiment he has repeated, and he has confirmed that there is a discovery of cathode rays. So the discoverer of cathode rays is Julius Plöcker. Julius Plöcker wants to just prove that gas conducts electricity. So he has given his experiment as a cathode rays experiment or electron discharge test tube experiment. There are some of the postulates of this experiment. In this postulate, he has taken so many things and he has considered that in this discharge test tube, first of all, he has given many other different gases. All the gases were ionized. He has thought that from the external electric current has been passed. So is there creations of electric field or magnetic field? So he has put in a magnet bar and he has seen that there is a large deviations, because if electric field and magnetic field would not be there, then there will be no deflections. So but it was a great deflection as he has seen, and he has proved that yes, there is a large deflection in these rays as we bring magnet near these rays. He has put one substance, that substance were heated by this cathode rays, thus it proves that cathode rays also has heating effect of electric current. He has put one metal which were having high melting point and boiling point. As this rays has passed through that metal, it has given the X-ray of that metal. He has again put a light wheel inside this test tube rays. Between those test tube rays, that wheel was starting paralleling inside it. Finally, it was concluded that in all the other gases, the same experiment has came. It proves that this cathode rays or this negative charge rays is the basic constituent of all the atoms. So all the postulates he has written at once, and he has given the confirmation that all the atoms, all the elements, all the gases constitute of the subatomic particle which is known as electron. Julius Plöcker has discovered cathode rays, And now electron is a negative charge particle which was given by J.J. Thomson. He has given the charge by mass ratios. These are all the postulates as I'll write on the board. Before writing, these are all the ideas which was developed by the classical quantum mechanics. You must write these points in your notebook. After that, you will write the postulates of this cathode ray experiment. Please take a screenshot or write in this notebook. Now, what had happened after the experiment? As the experiment has done, now the result was the observation of this experiment indicates that some radiations or rays are emitted from the cathode. These rays are known as cathode rays because it has been initiated from the cathode. So that's, you can see the result of this experiment. These rays are known as cathode rays because these observations were developed from cathode electrons. So that's why these rays are known as cathode rays, and the cathode rays stream from the negative electron, which is called cathode. As in the experiment, I have already shown you that in that evacuated test tube, one is electrode is cathode, another electrode is anode, and these rays have been developed from cathode electron. So that's why these rays were known as cathode rays. Now, what were the properties of these cathode rays? So, cathode rays are the fast moving beams of electrons. When they have been noticed that in this beam, which subatomic particle is there? So that was a negative charge because from the negative electrode it has been developed. So it will contain definitely a negative charge, and negative charge means an electron. So that's why the first properties of that experiment was cathode rays are fast moving beams of electrons. If I talk about the second properties, they are negatively charged, known from their deflection in external electrical and magnetic field. As we know very well that how they are negative or positive charge, because it has developed from the negative electrode as the electric current were passed and electric field and magnetic field were generated. So that's why here it is written that they are negatively charged particles. If anybody will ask you why negatively charged, then you have to say since it has been developed from negative electron, that's why. So they are negatively charged, known from their deflection, because it has been deflected from cathode. That's why it is written here. It is known from the deflection in the external electrical and magnetic field. Now, if I talk about the third properties of this experiment, that is, it started from cathode and ends at anode. This is the third property of cathode rays experiment. Now, if I talk about the fourth property, by changing the electrode materials and the gases present in that discharge test tube, there were no effect. There were no effect on the cathode rays. This proves that the atom or any matter whose these atoms are constituent of this negatively charged particle called electron. By changing the electrode material and gases, there were no effect on the cathode rays, which means that electrons are the basic constituent of all atoms. They penetrate through the metals and other substances and also produce fluorescence. From the metal, they have been seen that from the electrode, these rays are sparking and they have produced a green glow, that was a fluorescence, which has been obtained on the fluorescence screen, zinc sulfide. So, when the metals were placed, the screen were placed, so this fluorescence has been absorbed. An obstacle placed in the path of cathode rays is heated up. When any obstacle has been placed in the path of cathode rays, it has heated up. This shows that cathode ray possesses heating effect. Cathode rays on striking the solid objects of high melting point produce X-ray. When these cathode rays were struck with the high melting points metals, it produces they are excellent. Cathode rays has ionized the gases. They affect the photographic plate. They can ionize their gases. The E by M value of this cathode rays are constant. This E by M value, if we talk about, it was charge to mass ratio, which was given by J.J. Thomson in 1897. So that's why the discoverer of electron is known as J.J. Thomson. But he has given the charge by mass value in 1897. This proves that the E by M ratio is constant, whose value is 1.758820 into 10 to the power 11 coulomb per kg. So this was given by J.J. Thomson. That's why I have written in the point number 10, not 8, the E by M value is constant. Point number 11, cathode rays travel in a straight line. It also produces shadow as they deviate from angles to angle. Means just like other gases or other rays. Just talk about the sunlight or sun rays. As the sun rays fall on any object, sunlight always travels in a straight line. Similarly, cathode rays also travel in a straight line, and when any object comes in that between those rays, it gives a shadow. Similarly, this cathode rays also produces a shadow. When the light paddle wheel was placed between those cathode rays, they start rotating. They rotate a light paddle wheel if placed in the path, and thus shows that it is having a mechanical effect also. The cathode rays have been proved that it shows that it has a mechanical effect also. And the last but not the least, the charge on the electron was given by R.M. Millikan, whose value was calculated in 1906 by this R.M. Millikan, that mass of electron is the electron upon the E by M ratio, whose value was 9.1094 into 10 to the power minus 31 kg. So these all were the properties of cathode rays. First of all, cathode rays were developed by Julius Planck in the search of gases can conduct electricity or not. But as he has developed the cathode rays, he has seen so many properties as it is mentioned and described in the book. You must write this property into the notebook. The main thing, he has discovered cathode rays, not electron. Many of the students have got a doubt that, sir, who had discovered the electron? He has discovered cathode rays. Electron was discovered by J.J. Thomson. Now question is, this rays and electron is a particle and cathode is a rays. So this both property also will discuss when the topic will come that a matter is having a dual nature, either it is a wave or a particle. From that point also we will get the conclusion of this cathode rays experiment. So dear students, write this all the properties and the result of that experiment, which are very useful, because to understand a concept you must get a knowledge about that concept. So really this was a discovery of cathode rays. So dear student, if you have understood the concept about the cathode rays experiment, don't forget to like and subscribe the channel. Share this video with your friends so they can be also benefited during this pandemic situation. Rest things, discovery of proton or NR rays, we will discuss in lecture number 2. So by this way, I am ending the lecture 1 video. Thank you very much for watching. If you have any doubt related to this video, then don't forget to comment below this video. Whatever your doubt will be there, it will be discussed in the next video. That's all for today. Thank you very much. Have a great day. You can take a screenshot. If it is not visible, please take a screenshot. So everything you can zoom and write in your notebook. Or you can pause also for a few seconds. After pausing, you can take a screenshot. If still it is not visible, just wait for a few seconds. All the things will be hidden, then take a screenshot. So rest of the things, whatever I have written on the board, you can take a screenshot and you can write this, all the properties and the result of this experiment in your notebook. Thank you very much.